This is the video for CW 1.6. The Zoom recording didn't quite go through, so I'm just going to film it on my iPad. So let's do number one. It says find all values of k such that this equation has two distinct real solutions. So if you ever see a question like this, remember to use the discriminant. This is a classic discriminant question. If there's two real solutions, that means your discriminant, b squared minus 4ac, must be greater than 0. Recall that if it were equal to 0, then that's one real solution. And if it's less than 0, that means there's no real solutions. So quickly, let's plug it in. This would make k squared minus 4 is greater than 0. Now we're going to move that 4 over, and you square root. And this is the part we've been practicing in class. The root of 4 is simply 2. But the root of k squared, recall that this is the absolute value of k. And from here, we're going to do a little bit of logic. So we know that everything 2 and above is going to work. So I'm just going to write 2 and highlight this interval. Or in fact, I'll make that a open circle. It'll be a little easier to understand. And then also everything -2 or below -2 should work. So our answer is going to be k must be less than -2 or k must be greater than 2. And that's our answer. Next question. Let a be a constant such that the roots of this equation are r and s, okay, except for roots question. Find the value of this thing. So if you ever have a question like this, when it gives you the roots, so this is a classic Vieta's formula question. So we know we're going to have to use Vieta's formulas in some way. So let's start with the 1 over r squared. Add that to 1 over s squared. To add this, we just need our common denominator. So that's going to be s squared plus r squared over r squared s squared. And if you're wondering how I did that, multiply the left thing by s squared over s squared, the right thing by r squared over r squared. Now here's a part that takes a little bit of creativity. The bottom, we can see this is just rs quantity squared. And the top is a little complicated. The top, if I write this expression, we know that this is not equivalent. And the reason it's not equivalent is because this would be r squared plus 2rs plus s squared. So to make it equivalent, simply write minus 2rs, and that would now make our numerator equivalent here. Now the reason we do that is because now we can use Vieta's formulas. Remember, the sum of the roots is negative b over a. The product is c over a. So plug it all in. The sum of the roots are just going to be 6 over a, and the product is going to be 12 over a. And let's plug everything in. So we have 6 over a squared minus 2 times 12 over a, all divided by 12 over a quantity squared. Let's reduce that. 36 over a squared minus 24 over a, all divided by 144 over a squared, multiplied by a squared over a squared, and now we get 36 minus 24a, all divided by 144. And we can simplify that a little bit further to get 3 minus 12a, 3 minus 2a over 12. And that's when you divide everything by a factor of 12. Now for our last question, the sum of the squares of the roots is 10. That's important, so I'll highlight that. And it says find the absolute value of h, and there's our equation. Okay, so first thing I'm going to do is make the equation equal to 0. So I know that's our standard quadratic equation. Now the fact it gives us is r squared plus s squared is equal to 10. So that's a given fact. Now again, whenever we're given something with the roots, this is a big hint. We're going to have to use Vieta's formulas in some way. So let's write out what we know. We know the sum of the roots is negative b over a, so that would be negative 2h. We also know the product of the roots would be negative 3. Now this is a part that's a little bit complicated. We have fact number 1, fact number 2, fact number 3. This takes a little bit of intuition. What we're going to do is actually square this middle equation, because now we get r squared plus 2rs plus s squared. That's equal to 4h squared. Because, look at this, we have rs equals negative 3. Rs is right there. So that thing is going to be negative 6. 2 times negative 3, negative 6. Now we also have r squared plus s squared equals 10, which means this plus this has to equal 10. And now look at that. Now we have 4 equals 4h squared. h squared equals 1. We square root. 1 is the absolute value of h. And we could keep going, right, because we know that h would be plus or minus 1. But look at what we're trying to solve for. We're solving for absolute value of h, which means, don't do this. We have it. It is 1.